In this instructional video, I'm going to show you how to properly prepare and terminate the new standard low loss cable for Marlink. Our new standard low loss coax cable is the Cellflex LCF12 and it is more stiff and provides a lower degree of loss than the Cellflex SCF12. Just like the Cellflex SCF12, it comes with a mandatory connector for the cable. The difference is that the connector is bigger and it comes with a spring that's put on top of the outer conductor. In addition, you get a little tube of silicone that's going to go on the O-ring. Just like for the Cellflex SCF cable, Cellflex provides an optional trim tool for the LCF cable. If you do not have this trim tool, it may be replaced by a ruler, a file, and a flat screwdriver. You begin the preparation of the cable just like with the other cable. You cut the cable to the appropriate length of your installation. Once you have cut the cable to the proper length, support the cable on something stable. And then grab your bow file and then perform a straight and clean cut through the cable. The difference with this cable is that you're going to cut in the bottom of the valley of the corrugations in the cable. So as you can see, the cable has small bumps that go up and down. You place the blade of the bow file down in a valley and then you start cutting carefully. For the next step of the preparation, you will need a measuring tool, either a ruler or a set of calipers. Place the ruler on the tip of the cable and measure out 25 millimeters from the cut. Then grab your carpenter's knife and place the blade where the 25 millimeter mark will be. If you made a proper cut through a valley in the cable, you will see that the blade of the knife will also be placed on a valley at the 25 millimeter mark. Make a careful cut around the cable jacket, and at this stage you don't need to put much attention to detail. The main thing is that you get the cut done and are able to strip the cable jacket. For the next step, grab the trim tool and enter the cable inside the trim tool. Inside the trim tool, you will see a stop that will go inside a valley on the cable. Make sure that that stop goes into the second valley. So right here we have the first valley and the first top, which is partly covered by the cable jacket. Place the stop inside the second valley. Then turn the trim tool in the indicated direction a couple of times until you feel that the trim tool has cut through the outer conductor of the cable. And then you remove the trim tool. In the next step, grab the pliers and then just rip off that part of the cable that the trim tool has cut through. After that, grab something out of plastic which is softer than the copper of the center conductor and carefully clean off the remains of the dielectric foam from the center conductor. It is important that you do not scratch the center conductor and you achieve a perfect surface. As you can see, we have achieved a perfectly clean surface on the center conductor. There is no transparent layer of dielectric foam left on the cable, and there are also no scratches. In addition, I have removed all of the burrs that will come out from the foam just at the edge there where the center conductor comes out. In the next step, grab the carpenter's knife again and make a small slit in the cable jacket here. Then just pull off the cable jacket by hand and it will come off naturally where the trim tool made the cut. In the next step, you're going to measure out the correct dimension of the center conductor. The length of the center conductor should be 8.5 to 9 millimeters. So place the ruler on the center conductor. Make an accurate measurement and then place the saw on the 9 millimeter mark. Consider the width of the bow file blade. When you make the cut at 9 millimeters, the center conductor will end up a little bit shorter than that. Also, be very careful when you do this, because it is very easy for the saw to slip and make scratches on the center conductor that you are going to use. So take it easy in this step. Next, perform a control measurement of the length and make sure that the length is according to specification. If you have cut too much, then you need to do the preparation all over again. If you have cut too little, then you can just grab a file and file the center conductor a little shorter. Once you have confirmed the length, grab the trim tool again and put the tip of the center conductor inside the sharpening hole. And then just start turning about 20 to 30 times on each side of the center conductor. Now the preparation of the cable is complete. As you can see, we have a straight and clean cut through the cable jacket, an undamaged outer conductor, a clean cut through the outer conductor, and no burrs sticking out of the foam. It is also important to note that we have one valley here and then half a top here where the cut goes. In addition, the surface of the center conductor is clean and we have a conical shape at the tip of it. Now you're ready to mount the connector on the cable. First, grab the O-ring and put it on the cable. It's a bit stiffer than in the SCF connector, so be careful to not cut it at the edge of the outer conductor. You place the O-ring in the third valley counting from the cut in the outer conductor. After that, grab the silicone that comes in the packaging and put a small layer of silicone on the O-ring. Next, take the first part of the connector and put it on the cable and just push it on until the outer conductor protrudes. After that, take the spring and put it on the first valley of the outer conductor, like this. Then take your trim tool, put the center conductor of the cable inside the hole that is marked 1/2 inch C02, and then just push the trim tool in and turn in the indicated direction. This will expand the outer conductor and lock the spring in place, and then ultimately lock the connector on the cable. As you can see, we have opened up the outer conductor. In the last part of the preparation, you're going to grab the second part of the connector and just push it on the center conductor, like this. Then make sure that the first part of the connector is straight, and then you are ready to tighten it with your spanners. Grab your spanners, set them to 24 millimeters, and place them on the connector. And the difference with this cable is that you're going to hold the second part of the connector, and then you're going to tighten the first part. And then just keep tightening until it comes to a natural stop. You will see how the gap will close and the O-ring on the first part of the connector will be squeezed together. This is how the finished product should look. If I try to pull or twist the connector on the cable, it will not move. The next step for this cable operationally would be to put another connector on this cable and then weatherproof whatever connector that would be exposed to weather. After that, you would perform a cable loss test to ensure the quality of the cable and also the terminations you have made. Thank you for watching and see you next time.